Thea Fair is a powerful tool for adding realistic fair strands to your scene objects. With its extensive options, you can control every aspect, adding depth and realism to your projects. Let's explore its features in a simple scene. The Fair tool is found in the Object Settings tab. The Fair properties become available when an object is selected. The strands take their color from the object's material. The segment's value controls the subdivision of the strands. Increasing this value affects the shape of the strands, but remember, higher segment values require more memory and conversion time. Density controls the number of strands per square centimeter. Increasing this value results in a denser distribution. Length changes the overall length of the strands. Adjusting this value can help achieve the desired look. Thickness affects the overall thickness of the fair strands, allowing you to customize the type of fair you want. Fuzziness adds randomness to the strands, breaking up uniformity and making them appear more natural. Top thickness affects only the tip of the strands, unlike the thickness parameter which applies to the whole strand. The bending parameter adds randomness to the strands. A 0% value results in fully straight strands, while increasing it makes them appear more natural. Direction and direction axis control the direction the strands lean. Adjusting this value can change the strand's orientation based on the X, Y, and Z axis. The material drop-down gives us the option of either using the material of the surface or select one of the scene materials. Gravity simulates the effect of gravity force by pushing the fair strands in the world Z-axis. Instead of using fixed values, you can use a range or bitmap files for the parameters. Define a range by unlocking the minimum value and setting extreme values to see the effect on the strands. Alternatively, use a bitmap file to randomize the parameters. The maximum value applies to white areas of the bitmap, and 0 applies to black. Let's move on to the optimization section, where we have 3 options to optimize our scene in terms of memory usage. The first one is the Hidden Object Elimination option. When enabled, it removes any fair strands that are hidden by the object itself. We will check the option and move the camera to see how that affects the distribution. The value is the angle of the camera view and the surface normals. Higher values will remove more strands. Let's try using a different value. With the Exclude of Camera option, fair strands that fall outside of the camera view will be removed. Keep in mind though that it will not remove strands from the back side of the object, since they are considered to be inside the camera view. Having both Exclude of Camera and Hidden Object Elimination helps in removing the backside strands. Let's move on to the last optimization option that affects the segments of the strands. The value defines the distance in meters, where the segments will gradually start having reduced segments. Let's switch to a side view and measure the distance from the camera to a given point on the surface. The distance will be used in the adaptive segment's fall-off value. We will enter the value in meters. As you can see, the segments closer to the camera have the full segment's value. If we move away from the original camera location, we can see that strands have way less segments. Let's move to a different scene where we will be adding fur to the blanket and the rug. This brings us to the end of this tutorial. Thanks for watching.